And well, my name is Sean Hall, like you said, and I'm excited to do this webcast today. We're going to talk about MySQL Replication, and specifically, we're going to discuss how you can make MySQL's replication robust. So we're going to go over auditing, testing, and verifying your MySQL replication.
And Sean, one interruption, excuse me. We're already getting comments that we've talked about this before, you'll need to speak up and make sure you're speaking directly into your phone.
Okay, okay.
And be very conscious of that.
All right. So let me move on here to the first slide. So I guess to start with, I will give an overview of MySQL replication. And this isn't an extremely in-depth overview. The presumption is that hopefully most of you already have some experience with MySQL's replication. But just an overview will help understand how the moving parts work together. So when MySQL replication is set up, the master begins recording changes to the binary log. Whenever queries come into the database and are committed, they're written to their binary log. The slave will then keep an eye on that file and copy those transactions across to the slave's relay log. And that's done via the I.O. thread on the slave. And we're going to come back to the I.O. thread and the SQL thread, which is why I'm introducing them now. And then the third piece is that the slave monitors the relay log, and as transactions appear in there, it applies them on the slave database. And it does that by executing those statements just as it did on the master. So it actually reruns or replays those queries. So if the queries involve a join or a sort or things of that nature, it will execute those queries again on the slave. And that's rather important as we go through this. You'll see specifically why we emphasize that point. So let's see, move on here. So MySQL's replication has a number of limitations, and any of you who've had replication in production for any period of time have probably encountered some of these limitations. In my consulting here in New York, I encounter a lot of clients that have similar issues, and they often have issues with replication where over time they're receiving errors in the replication log, and they're not obvious as to what's going on. I mean, you see duplicate rows, you see a lot of strange things. And it's only when you dig into the inner workings of replication that you realize that actually MySQL has certain limitations, and if you take those into consideration in building your code and running your database, you can avoid a lot of those issues and make replication much more reliable. So here I'm discussing some of the types of things that can happen in your code that will basically cause problems with replication. So one example is if you mix transactional and non-transactional tables together. So MyISM and InnoDB tables in the same SQL query can cause problems with replication, and that's to do with the fact that InnoDB tables are transactional. So by their very nature, if you commit or roll back a statement, that will or won't show up in the binary log, and therefore won't be applied on the slave. Whereas transactions against MyISM tables get written to the table immediately. So if there's an error halfway through the execution of the statement, half of the changes may have been made to the table. So again, that behavior can be different on the slave, and again, that's to the nature of MySQL's replication, and that is that the code is being re-executed on the slave. So the other instances of problems are any areas in your application code that use non-deterministic functions. And what that means is functions that will behave potentially inconsistently between the master and the slave. One example is these functions that I've listed here. Sysdate, which by its very nature is going to be different on the master and the slave, perhaps by a half a second, perhaps by 10 seconds, depending on how much your slave is lagging behind the master. Current user, load file, UUID, these are all functions that potentially could behave differently on the slave. So if you have these functions in your application code, they might break replication. Also, if you use session variables, the example that I have here shows how you can use a session variable. This is not compliant with MySQL's replication and can break on the slave database. And there are also instances where if you use locking functions, you can run into problems as well. So what does all this mean? This basically means that in order for to get your replication up and running smoothly, you really need to audit your code for these types of problems and issues. And actually, the MySQL documentation has a whole page on what they call replication features and issues. Basically, that is things in your code that would be non-compliant or incompatible with replication. So you need to look for these functions, and you need to look for statements or queries that include both transactional and non-transactional tables together. Those are some of the bigger areas where you'll encounter problems with replication. So let's move on to testing. So you have your setup, you have your master and your slave, you've audited your code. The next thing you want to do is you want to be testing to make sure that the slave is up and running, and the way to do that is to watch the slave status for these two statements. Slave IO running, as I spoke about earlier, refers to the IO being copied from the master's binary log to the slave's relay log, and usually that doesn't encounter a problem unless there's a network problem.
Hey, Sean?
Yes?
We had a question. I don't know if it is on topic right now, but Matthew is asking whether it's better to use transactional tables or non-transactional tables.
I am going to talk about that a little bit more in depth, but the short answer is it's probably best to go with InnoDB tables. If you're going to use a mixture, just make sure that they're not in the same SQL query, that you're not mixing tables within one statement. That will help to avoid the problem with the slave encountering errors. So.
Okay, you'll go into that more in depth.
Yeah, exactly.
All right, thanks, Sean.
So yeah, so the second thing you want to watch for is slave SQL running. Usually, the problems that I'm listing here will cause an error in the slave, and this slave SQL running will stop, and it'll say no here. So I'm going to show you this on the terminal window in a few minutes, so you'll see exactly what I'm talking about. And I speak about Najos here. Najos is an open source monitoring system that can monitor all sorts of things from servers and the database running to MySQL's replication, and it has a plugin. It includes a plugin specifically for monitoring the slave. So if you haven't checked out Najos, I would recommend that. And the other thing you want to do is monitor the slave's error log. Monitoring that for errors and/or monitoring this slave SQL running are the most important things. So we moved on to the to the last step, which I'm calling verify. And what I'm going to do with this step is I'm going to take you through an actual demo on the terminal window, which will demonstrate the use of this tool, MathKit. So what MathKit does is, well, actually MathKit includes a lot of different tools, and specifically for our purposes, I'm talking about this checksum tool. The checksum tool will basically read all of your tables on the master and build checksums for those. This is similar to the Unix sum utility, or is it MK's M5 sum. But basically it does checksums on the tables and then dumps all those checksums into an additional table, and then that table of checksums will replicate down to the slave. And the reason why that's important is that when you go ahead and do the check again on the slave database, the timestamps are different. So the reason why it passes the information through replication is so that those timestamps will be consistent across all your slaves. So you know, that's important, and that's why this MK table checksum tool works so well. And again, I'm going to demonstrate exactly how to use the tool. So let's see, move on here. So here's what I'm going to run through with the demo, and as soon as I pass this slide, I'm going to open up the terminal window. While we're kind of, I actually already have MathKit installed. I just wanted to mention it here as it's a requirement. DBI and DVD MySQL are Perl modules, and MathKit are all Perl utilities. So I'm going to install the MySQL Sandbox, which is a tool written by Giuseppe Maxia, which installs a master and slave replication setup in a couple minutes, right in your user terminal. And the exciting thing about the Sandbox is that it installs without having any privileged users. So if you have a server and you want to test replication, you can install the Sandbox pretty much in any user account. So after we install the Sandbox, it starts up the master and slave database, and then we're going to perform checksums on the master tables. And then we're going to go to the slave database. We're going to verify using the MK checksum tool again and show that there's no differences. Then we're going to add an error row. Basically, we're going to add an extra row to a table on the slave that wouldn't exist in the master. And then we're going to do the same check again to show that the tool MK table checksum is actually showing us there's a difference between the two, the table on the master and the table on the slave. And then the last step is we're going to fix that using another tool that's part of MathKit, and we're going to verify that as well. So we're going to take you through each of these steps, and hopefully that'll illustrate really clearly how you would verify your MySQL replication setup. So what I've done here, I hope the font is big enough for everyone to see. If there's trouble reading that, please let me know.
I think it's coming through perfectly.
Okay, good. So what I've done is I've created a few scripts, these SH scripts, which all are basically just to encapsulate the commands, so I won't have to remember the commands specifically. So what I'm going to do is go through each step, and I'm going to show you the command, and then I'm going to run the script itself. So okay, so let's see. So create sandbox is the first step, and let's see. what's it going to do? It's going to run this command, make replication sandbox. And it takes as an argument a MySQL binary tarball. The reason why is it's installing all this in a user's account, so it's not a privileged account. So the easiest way to install it is that way. There is also a way to install it. So that's the sandbox, like I said. Yeah. So it's going to run make replication, and this is just a Perl script that's going to run through and do for us. So that's why I created the script. So it's going to run exactly that. Just run the create sandbox. So you can see it's installing, starting the master, installing, and starting the save. The way it does this is that it starts MySQL on unprivileged ports. So normally MySQL is running on, I think, 3066, something like that. These are all running on very high numbered ports, which are accessible to anyone. So by specifying the socket and the port in all of our commands, we can access instances on the same machine where there may be other instances of MySQL running. So what we've done here is we install the sandbox, and we have a master database and 2 slave databases running now. So let's see here. Connect to master. Now here's how you connect to master. Like I said, these are normally you wouldn't specify the port in the socket, but in our case, these instances are running on unprivileged ports. So I already went through the documentation to find out what it starts at, and it starts those at 29,472 as the master. So I can connect to the master that way. And we're going to run this tool here, this script. So I'm going to create a couple tables here. Create them in the test database, and I'm going to create this checksum table. This table is used specifically by the MK table checksum tool to store the checksums on all the tables. So you need to create this somewhere in your database. I'm just putting it in a test database. And the second thing I'm doing is I'm creating a test table, and this is the table that I'm going to be using to demonstrate adding an extra row on the slave. So let's go back to the master database, and I'm going to run source cr check test.mysql. So there it created the first table, checksum. Second table was shown test, and then it added 1 row of data on that. Now let's go to the connect slave, just to show you here. Connect slave. Again, I'm specifying the port is 29,473, and the socket to that different instance. So connect slave. Use test, and select star from Sean test. So there's our table that we just created. It's replicated to the slave now. Okay, so the next thing we're going to do is we're going to run the checksums on the master database. So I have a script to do that. Checksum. Okay, so this is the command that you would use to perform checksums on the master database. Most likely you'd probably run this from cron periodically, say once an hour or once every few hours, and it performs checksums on all your tables. And then you can go and do a similar check on the slave database to verify that everything's consistent. And basically, it'll compare all the checksums on all the tables on the slaves to make sure that they're exactly the same. So here again, we specify the socket and port. In your instance, if you have separate servers for all these, you probably won't have to specify those. Specify the user, the password. Chunk size is, if you have really, really large tables, this will perform the checksums in chunks, so it won't lock up the entire table. And here we're specifying the checksum table. This is where it's going to store the checksums. And then last, we specify localhost, which is where the server is. So I'm going to try to open this window a little bit longer so you can see what's happening here. Checksum, master. So most of these are internal, but the main one that we're interested in is here, because I only created one table. And there's this row. This is the row count here, saying there's one row. So we've created a table on the master. We've performed checksums. Now we want to verify that everything is correct on the slave. How do you do that? Use the same tool with a slightly different option, which is this replication check. And again, here we're on the same server, but we're connecting to a different socket and a different port, and that's how we know we're connecting to the slave. And this replication check 2 is through recursive checking. It's probably a little bit overkill in our case, but basically it means check the slave and check the server, the slave, and the slaves for differences. So we buy the slave, no differences, so it comes up blank here. So now what we're going to do is we're going to go into the slave database and go use test. Select done. Sean test. Insert into Sean test values. So commit and click that. We do the same verify again. Now it's still coming up blank, so you might wonder, well, what's going on there? The reason why is because the checksum that we performed on the master was before we made this change. So that's exactly why you need to do the checksums periodically. It's only going to checksum for that moment in time. So we'll perform the checksums on the master again. Let's say checksum master again. Now we do the verify again. And there's a difference here. This is saying, hey, look, your slave database contains the same table, but there's a different number of rows. And it's not giving you specifics. It's just telling you basically that its checksum is different. But it turns out that MathKit includes a tool to go ahead and fix those differences. So just to show you again, use test. Select start from Sean test. So we have 2 rows in the data in that table. What we're going to do is fix those to be exactly consistent with the master. So I have a script already set aside here to fix that. So MathKit's tool to fix tables is called MK Table Sync. And basically the sync to master, I would think the option would be better named sync from master, but at any rate, it syncs the table to be exactly like the master. Again, it's using this checksum table, and this long convoluted string out here is telling it which database to connect to. The reason why the syntax is screwy in this tool is that there has to be a way to specify multiple databases because they want to be able to specify the master, slave 1, slave 2, and so on. So that's what this syntax is for. In our case, we're just connecting to the slave. We're specifying the port. We're specifying the socket, the user, the password. And we're being very specific. We're actually specifying the database and the table name. But you could conceivably just specify the database, and it would do the entire database. So, so that's the sync tool, and we're going to run that. Now let's connect to the slave and use test star from on test. So you can see that it. Yes.
Someone's asking, can you do this while the master is being updated, or do you need to stop the master before you run this?
No, you can do it while the master is being updated, and that's because of the nature of the checksums. You know, the reason why I illustrated before how we did a verify and it didn't show the difference is because when you do a checksum, it's like a snapshot in time. So it's going to fix it against the last snapshot, right? So if there are other changes in the database, it's going to fix the slave against that instant in time. So it knows how to be smart about a moving target, basically. So yes, you can do this while the master is making their changes to the master. Okay, so yes, I verified. Let's see, we demonstrated that the cleanup is done. Now we'll go ahead and do the verify again, and it's still showing that the there's a difference, and that's again because of the checksums. It's looking at the database at a previous point in time, basically, and the checksum. So what we have to do to fix that is to redo the checksum on the master and then verify again. And now we are back to a clean slate. So we know that the master table Sean test is exactly the same as the slave version of Sean test. And so basically we've illustrated how to use the MATKit MK table checksum with a very simple example. Again, the reason why the illustration is important is that there's as we reviewed earlier, there's a number of situations in MySQL code where you can have non-compliant statements that'll execute differently on the slave database, and when that happens, you can get duplicates, you can get you can get missing rows and things of that nature. And so the only really way to guarantee that your two databases are the same is to use a tool like this to compare exactly the contents. I mean, even counting rows on the master and slave would not be sufficient to guarantee that your master and slave are exactly the same. So I really recommend anyone who's running MySQL Replication to look at this tool. Back to the comment that an attendee participant asked earlier, can you use this tool while the master is running? Yes, you can use it while the master is running. There is one situation where you want to be careful, and that's if you're using what's called circular replication or master-master configuration. And what that is when the configuration we've described here is where you have a master and it's sending changes to the slave, and that's the entire configuration. But there's another way to set up MySQL's replication called circular replication, and in that configuration, the master is also set up to be a slave of the slave database. So changes originating from the master will be sent on to the slave, applied to the slave, then they'll go into the slave's binary log, and the master will see them. It will copy them back to its relay log, and then see that the server ID is its own server ID, so it won't apply them. The reason why you'd want to have circular, the reason why circular replication is somewhat common is that it it's very simple to fail over and fail back. But if that's the configuration you're using, you have to be careful with this tool, because this tool is making changes to the slave database, and they would then be applied to the master. So that won't work if you're using master-master or circular replication. You'd have to find some other way to fix your differences in the table. Okay, so that's okay. Other stuff in here. So basically here I'm in the presentation, I'm just running through the stuff that we just went over on line. Now, there were a couple of other attendee questions that we got before the presentation started. And one of them was, one person asked about, can you move your database out of the default var-lib MySQL location? And the answer is yes, you can. There's a couple parameters that are specified in the my.cnf file, specifically the data dir and the InnoDB data home dir. The data dir will specify all your MyISM tables, your log files, and default locations for other files. And then the InnoDB data home dir is where your InnoDB table spaces will be put. So, if you wanted to have an additional partition added to your server and you want to move data files there, you can do that with these parameters. Another question that I got before the presentation started was, and this is a pretty good question, it refers to transaction-intensive environments. If you have a huge stream of transactions on your master database, there are times when you have problems with you become a performance bottleneck on the slave. The reason why is that all of the writes that originate from your master database are serialized on the slave. What does that mean? Well, on the master database, you have hundreds and hundreds of sessions connecting to the database, so separate threads doing work in the database at the same time. But all of those get serialized. In other words, they all stand in line one after the other on the slave database, and that's because of the nature of the IO threads and SQL threads that I referred to before. So basically, we copy all the changes to the relay log with the IO thread, and then the SQL thread on that slave database then applies those changes one by rerunning those queries. So what are some ways that you can speed things up? Well, one way potentially is you could break all your databases up into separate slave servers. And you can do that by using replicate do database and replicate ignore database. So effectively you would create one slave server for databases 1, 2, and 3, and then another separate server for 4, 5, and 6, and so on. So you'd have physically separate servers. Another interesting option to use is called priming the cache. The MacKit also includes a tool that does exactly that. It's called mkslave prefetch. What does this do? Well, it looks at queries that are running on the primary master database and then pre-runs them on the slave database. So you might ask, well, why would you want to do that? And the answer is that the nature of statement-based replication means that each of the queries that ran on the master have to run again on the slave. So if you have complicated joins and sorts and things of that nature, those all have to run again, and they have to cache the data, and then they have to write the data to the appropriate tables. So by using this mkslave prefetch, you're priming the cache. It's effectively you're running those queries early so that by the time the slave process reaches the statement, some of that data will already be cached, and therefore it'll run quicker. So it's an interesting way to potentially speed up slave replication. Another option, possibly, and I haven't done performance benchmarks to prove it, but is row-based replication is available in 5.1, and depending on the SQL that's coming down the line to the slave database, some stuff is done as row-based and some is done as statement-based. So the row-based data will probably be faster to apply in the slave database because it doesn't have to rerun those queries. So I would expect there's going to be some speed up there. Another option is to use potentially a different storage engine on your slave database. So suppose your master has 100 tables and they're all InnoDB tables. The reason why you want InnoDB tables is you want to have transactional support so that you can commit and roll back changes and have row-based granularity so that different transactions or different sessions can be making changes in the same tables. But on the slave database, that's not really required because, as I explained before, all changes are serialized, so their statements are made one by one. So since that's the case, MyISAM could be a good bet for you because MyISAM is extremely fast in terms of its write performance, and so using a different storage engine on the slave could potentially speed things up a lot. Let's see. The other thing to keep in mind is that lag on the slave is normal. So if your application is expecting all the data to be synchronous, you're making assumptions about how our application works that are really not compatible with the application. So you should really look at specifically how your application works and how to solve the problem the right way. Another way of potentially speeding up things is data archiving, i.e. doing the writes outside of replication. So if you did a large data load for reporting, it may be that you want to do that outside of replication. Don't load the data on the master, or load it on the master and then use replicate ignore database and then load it separately on the slave. So it will happen, again, outside of replication. And there are also some other ways that you can speed up things, potentially trading safety for speed, like disabling the binary log on the slave server. That may or may not be prudent in the long run, but could potentially speed up performance, so something to consider.
Hey, Sean.
So, yep.
David, do you see that question by David at the bottom of your screen? If MyISAM is often corrupted in the master, can you
okay. The question is about MyISAM tables in corruption. You're right. You don't have the transactional protection, and you don't have the recoverability with MyISAM tables that you do with InnoDB tables. But the presumption is that your slave database is a reporting database, and that it could potentially be rebuilt. So we're looking at trading off that recoverability for performance. So you're balancing between the two, I mean, presumably you're not using your slave as a backup. I mean, your backups should be done separately anyway. You should be doing dumps of your data, and you have all the original data on the master. So the slave is really most likely used for reporting or read-only queries, and in that case, using MyISAM tables may help with performance, and it may work for your environment. Let's see what else. I followed up with a couple slides on. These are two books that I would recommend that cover replication in depth, and if you don't have, I would definitely take a look at those. And then there's a few blogs that I think are very good. data charmer is Giuseppe Maxi. He's the one who wrote the MySQL sandbox, and his writing is very good. And MySQL performance blog is Zoladny's blog. He's one of the authors of the previous high performance MySQL. Okay. So here's my conclusion that MySQL replication is very powerful, but unfortunately reliability is not automatic, and this may not be obvious at first sight. You might assume that you have your server set up and Slave is running, so I'm going to get an error if something's failing, but that may not be the case. In fact, consistency is not automatic either, and that's a really important thing. I mean, I suspect that most of you, if you've never used this checksum tool and you go out and checksum your master and take a look at your slave, you're going to see differences. And that will probably surprise you because basically, replication is, in my view, failing, but it's not failing with an error. So again, you need to be vigilant and you need to use the right tools. And I think MatKit is a very good tool to look at to take care of some of these problems. The exciting thing is that the MySQL developers knew about some of these problems for a long time, and they've addressed them in 5.1, which is now generally available. And 5.1 has something called row-based replication, and what that means is the 5.0 and previous versions are statement-based replication, which in the other database world is often called logical replication because it's taking the statements and rerunning them. But with row-based replication, you're taking the actual data, or what are called change vectors, which are differences between the old data and the new data, and so potentially 5.1 could solve a lot of these problems. I'm not sure if it solves all of them, and we'll see, how it performs and if there are bugs and so on. But that's worth taking a look at. So yeah, thank you everyone for a chance to talk. And if anyone needs to get a copy of this presentation, feel free to email me. This is my Gmail account. And I guess now maybe let's open it up to other questions.
Sure. Sean, a couple of people have asked, before we jump into questions, now you've closed it out, they wanted to see your slide on book references and and the links that you showed again. Okay.
These are the two books. High Performance MySQL. This is the second edition. It just came out I think it came out in November.
Last year. Oh yeah, recently.
Yeah. And that's really chock full of very good information, technical information, and real-world kind of practical information about running MySQL. And I highly recommend that book. I mean, it's full of page after page of useful information on. It has a whole chapter on replication that covers all this stuff very thoroughly.
And another person asked, I think people also wanted to see the next slide, this one with the further reading. Right. And then while you were speaking, another gentleman asked me if you're going to share your scripts. And I said I would ask you afterwards.
Sure, I'd be glad to. I mean, the scripts that I wrote basically encapsulate the commands that you would actually run at the command line. So they, basically they're one-line commands to connect to the sandbox master, connect to the sandbox slave, run the checksum. But yeah, I'd be glad to share those commands. I can, not sure what the best way to do that. I mean, I could probably just put together a web page or something for maybe, Catherine, maybe there's a a way that I can, if there's a good, convenient way of putting them up on the O'Reilly site, or...
Believe it or not, that's trickier than you think.
Okay.
But we can figure something out.
Yeah. I mean,
how large?
Yeah.
How large a file would that be?
It would just be a very small text file. It's just going to be a handful of commands.
Then if you can put it together and send it to me, people can just email me, which is webcast@O'Reilly. Let me type that in.
Sure.
It's not plural.
People should feel free to email me as well.
Okay.
And if you have any questions, or if you want a copy of the presentation slides.
All right, and we're also recording this, and we'll have a recording of the entire presentation available afterwards, probably in about a day. But we also have a few questions here. Are you ready?
Yep.
Okay, so back when you had just begun your demo, Carlos asked, will specifying the chunk size be effective in avoiding long locks with tables that use table-level locking?
Yeah, that's exactly what it's for, Carlos. The MK checksum table tool is reading the whole table to perform the checksum. So the chunk size can be adjusted to protect against locking too many rows at the same time, and that's exactly what it's for. So it will definitely avoid contention by adjusting that value, and I would experiment with that to find out if it's impacting performance. I mean, it may be that you can run this less often. I mean, you might only need to run it once a day, and you could run it late at night and then do a check right after. I mean, unless you have a huge number of writes all the time, I would say probably once a day would probably be sufficient for most people.
Okay, and you may have just answered this question. Another gentleman was asking when you were doing the demo, how often do you need to run? And he said this command, but I'm afraid I didn't make note of what specifically you were doing at the time. I think his next question was about consistency, and he said it looks like you need to script around to check for database consistency. Is that right? Oh, replication checks. You were doing replication checks. I'm sorry.
Yeah, I was referring, let me go back to that slide here. Maybe it will help. Yeah, I would recommend using Nagios to do this. I can show you this in the terminal window. I don't think I demonstrated that. Let's see if I can. So connect slave and show slave status. And those two lines right here are the lines that I was referring to. All this other stuff is useful, but those are the main lines to verify. And then there's a line here. There's an error. Last error number here. And the error log for the slave will also show any errors that have encountered. But like I said, it's very possible that the slave can get out of sync with the master without any errors. And that's the thing that I think will surprise a lot of people. So, if you have some test databases that you've been running for some period of time, I recommend going and check something in your master and verifying on the slave, and I bet you will find some differences on some tables. And that's the kind of scary thing, because if you don't know that your data is different, you're not getting any errors, how can you fix it? So, that's why this tool is useful, is that it will alert you to those kinds of problems.
Good answer. Here's a question, and I'm going to reveal my ignorance here because I don't know how to pronounce these things. But and the person who asked this sent it to me directly. Can you please explain mixing INODB and MyISM in the same update statement? How will that affect replication?
It's basically not supported. And if you look through, let me see if I have that page open. This is the documentation at the MySQL site for what it calls replication features and issues. And you know, one of the things it talks about is if you do a search on MySQL replication mixing transaction non-transactional tables, you'll find some articles on Google. But basically, it's not, and it may or may not behave correctly. So you know, the recommendation is to not make them in the same statement. And if you have those mixed InnoDB and MySQL tables mixed, you should you know, you should take a look and essentially audit your code and change the storage engine of some of those tables, because they may not replicate properly or consistently.
Okay. And another person, Victor, was asking about database schemas, and he wanted to know what people are using to generate schemas. And one person replied and said that he does his by hand, so the data types are the best that they can be. And I wondered if you wanted to comment on that too.
Yeah, I usually make schemas by hand, or I mean, often that's in the realm of developers, and I'm usually the DBA that's like looking at things after the fact and saying, okay, well, this looks good and this looks good, but there's an issue here and there's an issue here. So yeah, I'm usually not the developer that's building you know, 100 tables for the first time, and then I'm usually looking at it as a DBA and saying, you know, this looks good and this looks good, but your data types here or your storage engine here is going to be a problem.
Okay. And here's another question that came in. Matthew was asking it. When would you look at 5.1 in production? He's heard that there are some serious potential issues at this point.
I mean, from what I've seen on the web, the issues were kind of overblown because of some bloggers that made some statements about it. I mean, 5.1 is generally available. Obviously, with the new version of the database, there are bugs, and you know, you shouldn't just jump into it on your production server. You should test it, you know, in development and make sure your application is running, and do some benchmarks and watch the error logs and make sure that you're not having any problems. It really depends on what features that you may or may not be using on 5.1. I mean, if you're going to look at using the row-based replication in 5.1, yeah, Matthew here is saying using 5.1 in beta production. I've certainly seen a lot of folks using 5.1 now, but again, it may depend on your specific environment and if your code is accessing some feature that has a bug or not. So.
Great.
Marcos asks where the presentation will be available. Marcos, I'd be glad to email it to you, unless Catherine maybe will upload it to the O'Reilly site. Or
well, how about SlideShare? Have you used SlideShare?
No, I haven't.
It's a great site for sharing presentations because you can upload them and people can view them, but they don't actually download them. And I mean, if you're worried about people stealing your slides, I never am. I would take that as flattery. But
not worried at all.
Okay,
like I said, I'd be glad to email them to anyone. I'll take a look at SlideShare and see.
Yeah. Like I said, it's not that easy to get something posted for download on the O'Reilly site. It's a little bit tricky, in fact. But if you want to email me at webcast@o'reilly.com, or if you want to email Sean, and there's his email as well, we'll be glad to make sure you get a copy of the presentation. And as I said, we're recording this, and we post that on our webcast page, and we also put a copy on YouTube. And I will send everyone an email to let you know when the recording's available. So you'll be able to watch the entire thing again if you like, or just parts of it. And we'll let you know that. And I think that's all the questions we have, and we're just about out of time as well. But I want to say, Sean, that you sure know your stuff. It was an excellent presentation, and I could tell by the comments that people got a lot out of it.
Great.
And I also want to thank everyone else who jumped in and to answer other people's questions. We appreciate that a lot. It's quite good. And if anyone wants to copy the chat window and save it, or save the chat, the best way to do it is to put your cursor in there and select all, and then copy and paste it in a text file, and then you have it if there was information in that you'd like to keep. And otherwise, I think we'll just, well, thank you again, Sean. Thank you so much for doing this.
Thank you.
And I hope we can have you back again in the future.
Absolutely. Absolutely.
Okay, good, good. All right. Thank you, everyone.